So basically, object-oriented programming is a different approach in programming where we think of the system as set of objects, right? Set of objects that communicate and collaborate to achieve the objectives or perform the system functionalities. So this is the thinking behind object-oriented programming, which is quite different from the other approach that we have been discussing so far, that is structured programming, right? So this is the difference between the structured software development, which we have been discussing so far, versus object-oriented development. In structured approach, our thinking is, so we have data, we process it to get the output or the result. So we represent data in variables. Then we apply operations with the help of control structures to get the output. It's something like a machine. We take the input and get the output. It's a very simple thinking, right? But it is very effective for simple situations. So that is how we used to program until around 1980s. But from 1980s, early part of 1980s, the object-oriented approach came. So the software developers came up with another alternative way of programming. With the C++ language, it became very popular. C++, then Java. So they start supporting object-oriented programming, and later on C# and so on. Okay, so here we think of the system as a set of objects, and these objects communicate and collaborate to perform the system functionality, so achieve the objectives. Okay, right. So that is the fundamentals difference between the structured development and object-oriented development. Right. So the next thing is, remember, this is the alternative approach, a newer approach. Okay, but it doesn't replace structured programming. Now, don't think that you have wasted your time learning structured programming. No. So when we are developing a system using object-oriented, still, yes, the big picture is object-oriented. But when it comes to implementing specific functionalities, still we use structured programming. So therefore, this is an enhancement to structured programming rather than replacement to structured programming. At big picture level, high level, we think in terms of object-oriented. But when it comes to solving the low-level problems or problems at low level, still we use control structures, operators. Of course, without that, how can we do the processing? Okay, right. Right. So these are the one-to-one comparison. So in structured development, we think in terms of control structures. Here we think in terms of objects and their interactions. This is a very basic approach, but this is a supplementary to the structured approach. This is relatively simple and this is relatively complex. Again, I'm using the word relatively. It doesn't mean that object-oriented development is very complex, but compared to structured programming, it is complex. Okay. So therefore, we use structured approach for developing simple systems, but for more complicated, sophisticated systems, we go for object-oriented development. Okay. The product that we develop using structured approach is less maintainable, less reusable systems. But when we develop using object-oriented concept, we get more maintainable, reusable, long-term maintainable systems. Okay. So structured development is good for developing simple systems, but for complicated systems, object-oriented approach is better. Right. So few points to remember, which some of the points I have already mentioned. So this is not trivial as structured programming. So in simple, object-oriented programming is not for kids. For example, you know that the programming is now taught even in schools. But what we teach at schools is structured programming. Even if you take something like A-level ICT, what we teach students is structured programming. because object-oriented concepts are too much for them, too complicated for them. So at degree level or after schools level only, we expose students to the object-oriented concept. So that means you need more focus, seriousness. You have to understand the big picture when it comes to object-oriented programming. Okay. So other thing is you need a lot of practice. You need to do a lot of coding, because when you do coding only, you understand the value of some of the things and some complications and so on. The other thing is object-oriented programming needs bit of modeling, upfront modeling. You can't straight away start coding, right? So you have to think about it, understand the requirements, identify objects, how they are going to interact, right? You need a bit of patience, right? Because we are using it for some serious software development like accounting system, ERP systems, and so on. Okay, so this is the real productivity you will feel when you are developing big systems, not when you are developing hello world sort of thing. So just system that we use to demonstrate object-oriented concepts. No, so there you will not get that feeling. Okay, so therefore the best way to further understand object-oriented programming is as quickly as possible start developing some serious applications. Okay, right. So we can understand object-oriented programming at 3 levels. So first you have to understand the basics of object orientation, like what is object, what is a class, what is messaging, what is association, right? Then of course, what is the instance variable, what is a class variable, what is instance method. So those are the things inside class. So that is your first step. So that is what we do today. So then once you are familiar with these concepts, we can go into the next level of concepts like what is abstraction, what is encapsulation, what is inheritance, what is polymorphism. So that will be covered in the next sessions, next 1 or 2 sessions. But that is also not the end of the story. So there are some advanced concepts when it comes to software development and architecture, like open close principle, inversion of control, design patterns. So those are not covered in semester 1. So those things will be covered in different other top subjects. Okay, so that is the idea. So we'll go on up to this point. But once you get into this point, you are in a position to start developing some serious applications. Okay, if you properly learn it. Right. So remember, this is software development is not just programming. We discussed the software development, software engineering activities, software development methods, and so on. So if you go for object-oriented development, you have to start from analysis. Right. So when you understand the requirements, also we try to understand as much as possible in terms of objects. Then design, obviously, we have to do using the object-oriented concepts. Then, of course, the object-oriented development or object-oriented programming. Sometimes we just say OOP. But testing is separately. So maybe unit testing is a little bit object-oriented, but the rest of the testing is just because now we have developed the system, we want to test the system. It doesn't matter whether it's a structured way we develop or object-oriented way. We just have to test the functionalities. Right. So let's move on to the object-oriented basics. So what are the 3 things you have to understand? What is an object? What is a class? What is mean by messaging, or what is mean by objects communication and collaboration? And what is mean by association of objects? Okay. Right. So let's start with object. Okay. So in object-oriented system development, we think everything as objects. Everything. Okay. So everything is object in object-oriented programming. So later you have the UI development as well, like that is one of your last topics in programming. So there even a window is an object. Right? A button is an object. Right? So that is what I mean by everything is object. Even the user interface is object. Database connection is also object. Now forget about the other things, right? So customer is object, employee is object, payment is object, order is object, vehicle is object, right? Use interface, button is object, window is object, database connection is object, and so on. So in object orientation, everything is object. So at beginning, it's little bit difficult for you to think like that. But once you get used to it, you will find that, yes, that is another way of thinking, right? Another programming paradigm. Okay. So in object-oriented programming, basically object is anything that we are interested. Anything that we are interested or related to our system is an object. Right. So another name for object is entity. Remember the very first day we discussed that what is data, what is information. We discussed that data is properties of an entity. Then what is entity? Entity is anything that we are interested. Now we use the same name, anything. So remember we discussed three types of entities: living physical entities, non-living physical entities, conceptual entities. So the same thing is there in here because object is another name for entity. Okay, object is another name for entity. Right. So therefore, object can be a living physical thing, like a student is object, possible object, customer, employee, patient. Right. Living physical things can be objects. Non-living physical things or non-living tangible things can be object. Vehicle, machine, goods, right? A medicine can be object. And of course, conceptual things can also be considered object because everything is object. Payment, order, course, okay, reservation, bank account. So those are also considered as object because we have to consider everything as an object in object-oriented programming. Okay. So then, what are the things that we are interested about objects? So we are interested about two things when it comes to objects. We are interested about the object's attributes or properties. We are interested in objects' behaviors or services. Now, in structured programming, we take data and process. Data and process are separated. Data is one thing, and then we apply processing on those data. But in object-oriented, your object has both data and processing or services. That is why objects, so that is why we say object encapsulate data and processing or attributes and behaviors. So in structured programming, we separate it. We look at it separately. But in object-oriented, the data and methods or behaviors are taken as a one thing. Those are inside the object. So that is more, actually, this is more natural. Right? For example, if you take a human, so you have a set of data, your name, your age, and so on, and you have the behaviors. You do things. So therefore, separation of data and behaviors is the unnatural thing. Considering it as one unit is a natural thing. So therefore, in a way, object-oriented programming is more natural. Right? Once you understand it. Okay. Right. So what are the two things we are interested of any object? We are interested about the attributes of an object. If it is a customer, customer name, okay, customer contact number, email, then customer's behavior. If it is employee, employee's behavior, check into the work, check out from the work, apply for leaves, okay, and so on. Okay, so I will do a little bit slowly because this is a starting point. Right, so attributes are the properties of that object or the states. Whether account is activated, disabled, states or properties. Name, age, if it is an employee or something. So behaviors are the functionalities or services that is provided by the object, not provided to the object, provided by the object, or its behaviors. Behaviors. Now, this is a little bit tricky at the beginning. Of course, it's easier to understand these things for a human or the living physical objects. For example, you can say if it is just a human, the behaviors can be the person or human talk, right? Walk, run, laugh, and so on, right? Yeah, those are the behaviors. The properties are, attributes are the name, date of birth, and so on. So the tricky thing is understanding the behaviors of a physical, non-living physical things and conceptual things. Okay. So therefore, we'll look at one from each category. Okay. So this is an example of an object and its attributes and behaviors for an employee. Of course, employee is a living physical thing. Right. Check in, check out, appoint, employee number, date of birth, designation, those are attributes. So let's look at a physical object, non-living physical object. Registration number, date of registration, model, color, those attributes. Now forget about these behaviors, we'll take it a little bit easier. Forget about these behaviors. Now what are the behaviors of a car? Forget about these things, okay? Just consider car as an independent entity. Of course, someone has built it. Can someone tell me what are the behaviors of a car? That is, what are the things the car can do? Anyone? Just take car as an independent entity, object. Can someone tell me what are the behaviors car can show? I need 5 behaviors. Of course, the driver will call it. That is why we say driver. It is not driver's behavior. Driver just call it. But the behaviors are with the car, though it is a machine. What are the behaviors? Yeah, so we can start, okay? We can start the car so that actually the driver start, but driver call that start behavior by turning the key or switch. So then run, okay? Turn. So that is why it has a steering wheel so that the driver can message and call that behavior. Okay. Accelerate, decelerate, brake. So those are all behaviors of the car. Those are all behaviors of the car. Right? You can see that the car has behaviors. The driver is just calling those behaviors at different times. So that is what messaging is. Messaging is. Okay. Now let's take something like say blender. Okay, blender has only just 1 or 2 behaviors, right? So let's make it a little bit more sophisticated. What can we take? Something like maybe electronic fan. So we can start or switch on, not start, right? Switch on the fan, that is a behavior. Switch off, set the timer, set the speed. Okay. Can you give me one more behavior of a fan? Now I gave you few behaviors. switch on, switch off, set the speed, that is why you have 1, 2, 3 and so on. Set the timer. Can you give me one more behavior of a fan? Normal fan, pedestal or stable fan. Anyone? Yeah. So turn, enable or disable swing. So that is very good answer. That is another behavior that the fan has. We just call it. Okay, we just call it. Right. Now I hope you have reasonable understanding about what is meant by behaviors when it comes to non-living physical objects like a vehicle, fan, right, your washing machine, and so on. Now we move on to the third category. So this is where the things are a little bit more tricky. Conceptual objects. Because it's conceptual. Someone will ask, how can a conceptual object has behaviors? Okay. But we have to think like the conceptual objects also, of course, we provide those behaviors. Just like the vehicle also, it's we has built it, the start functionality, accelerate, and so on. But afterwards, we just think it like it is a behavior of the vehicle. It is a behavior of the fan. So same thing applicable for conceptual objects like a payment, order, bank account. So the very good example is a bank account. Okay. So everyone must be having a bank account, at least one or more. So understanding attributes are not difficult, right? Account number, what is the type of the account, what is the interest rate given to your account. Of course, the balance of your account, that is something that everyone is interested. So those are attributes of the object. And later we will call them classes as well. Now, what are the behaviors? Right? That means when you open an account, what are the things you can do to your account? Basically, account is in the bank, but you can do certain things to your account. Of course, with the help of the bank system or with the help of the bank staff, you can't just do it by yourself. You have to follow the procedures. So what are the behaviors of a bank account? So the most frequently we use, the two most frequently used behaviors are we go and deposit money, we withdraw money. So we withdraw from our bank account, we deposit to our bank account, or someone will deposit to our bank account. So those are behaviors of the bank account. So we can go to the ATM machine and withdraw money. We can go to the deposit machine and deposit, or go to counter and deposit, or we can ask someone to transfer money. So that is also invoking the deposit behavior. So the bank will call the add interest behavior at the end of every month. That is how your balance change. Okay. And you can see that these behaviors affect its attributes. Not every behavior. Some of the behaviors affect the attributes. Right? Its attribute, not other attribute. So when I call behaviors of a bank account, it changes its attributes. It cannot change other objects at data or the attributes. It can, when we call a behavior of object, its attributes can be affected. Values can be changed. For example, when I deposit, call the deposit behavior, balance increase. When we call the withdraw behavior, balance decrease. Okay. When we call the run behavior of a vehicle, its mileage increase, its fuel will go down. When we, now vehicle has another behavior called filling the pump your petrol. Then it will increase the fuel storage or the amount of fuel. So you can see when we call the behaviors of object, its attributes can be changed. not other objects attribute. Okay. Objects have the control of its attributes, not other objects attributes. If you want to change the attributes of another object, you or some other object has to call its behaviors. That is how object-oriented programming work. Okay, that is how object-oriented programming work. Okay. Right. So some of the confusions that those who are new to object orientation, of course, new to object orientation, once you are familiar with and once you have some experience with some coding, right? Not by reading books. You get the experience by coding, right? Hands-on working, not reading books. No, attending classes, you don't get experience, right? Experience is by doing things. So once you get the experience, most of these confusions will go away, but you must aware these things upfront. One is whether a particular attribute is for this object or that object. Sometimes you feel like it's an attribute of this object, but in reality, it will be an attribute of another object. So that you have to double check. That you have to aware that you can get into that kind of a traps. Okay. So most of the time, this object is associated with another object. Its properties you may feel like it is a property of this one. No, actually it is a property of the other object. Okay. So very classical example is when we say account, bank account, right? Of course, the bank accounts number, balance, interest rate, those are properties of the bank account. But a lot of people think that account holder's name is a property of the account. No. Right. Because, for example, your ATM card, maybe your name is there. Your bank passbook, your name is there. But it doesn't mean that it is a property of the bank account. It is a property of the customer, the account holder. So you have the account is one object, account holder is another object. So therefore, the name of the account holder is account holder's property, not the property of the account. Okay, not the property of the account. So just double check whether is it really a property of this object or that object. Okay. Because otherwise you model it wrong. Okay. Then the system is not stable, right? Functionality wise. Because you have messed it. Right. Another confusion is just like the confusion for the attributes, the confusion about behaviors. Okay. Is it a behavior of object A or behavior of object B? Sometimes the behavior of object A, you may feel like it's a behavior of object B when you are new. So very classic example is, now I told you that if you take a vehicle, it has the behaviors like start, right? It has the behaviors like start, stop, turn left, turn right, accelerate, decelerate, and so on. Those are the behaviors of the car or vehicle, right? Car or vehicle. But if when you are new to the object oriented, sometimes you may feel like, okay, those are the behaviors of the driver. Because driver drive, driver start. No, driver is, it's not driver's behavior. Driver just call those behaviors of the vehicle. Right? Start, stop, all are behaviors of the car. Driver is just calling those behaviors. Just keep that in mind, because the moment you model it to the other object, it doesn't work. Because you have not properly modeled it. Okay. That is why you have a separate subject called object-oriented analysis and design. There they check whether you identify those attributes properly, whether you have identified the behaviors properly, whether you have identified the objects properly. Have you identified the proper associations? So that is why they give you draw a class diagram and so on, draw a sequence diagram, check whether you have proper understanding about how the objects are working together. That is why I told you this is a serious stuff. Object-oriented programming is not for kids, not for school level. You have to get out of that. So this is for those who have the adult or professional mentality, not kids mentality. Okay. Right. So now we have discussed enough about objects, its attributes and behaviors. Now we want to discuss about class. Now, what are the three main concepts we want to discuss? Object, class, then for the attributes and behaviors of object or class, then messaging, then association. So those are the things that we discussed today. Because you must be really sure about what are those things. Again, I will tell you what are the things we want to understand today. Object, class, attribute, behavior, messaging, association. Because a lot of students think that when it comes to object orientation, it's all about inheritance. Right? No, it's not all about inheritance. Without understanding these things, no point learning inheritance. You never understand, you never develop systems without understanding the basics. Right. So now we move on to class. Right, class. So what is a class? Now we discuss object. So a class represents or models set of similar objects or set of same type of objects. So that is the definition of a class. So you must be very serious about the definitions of the basic concepts. Right? Object is anything that we are interested. Class is used to represent or models set of objects. To represent all the car objects, we can have car class. To represent all the employee objects, we will model employee class. To represent all the account objects, the bank will have hundreds and thousands of accounts. To represent all these objects, we model a account class. To represent all the payment objects, we model payment class. In our system, when we develop the system, we have just the account class. We don't have account objects in our code. Of course, we create objects also that I will explain later. So therefore, you must know what is a class, what is object. What is the connection between class and object? Okay. Right. So class represents or models set of similar objects. Okay. So that is the idea behind class. And once we model it, then someone will ask, why do you model it? Why? Because when you model the class, the object-oriented programming languages provide a mechanism to create objects out of that. So we model the class or code the class. So then we can create objects out of that. Therefore, it's something like a factory. Right? Or blueprint. Blueprint means like a seal. From that, we can create instances. Okay. So when you create an object from account class, what you get is account object. So that account object has the attributes and behaviors for account. When you create object from employee class, what you get is employee object. From Apple class, you get Apple objects. From Orange class, you get Orange objects. Okay. So that is how you explain class. If someone asks what is a class, you can give two things. A class models or represents set of similar objects. Then someone will ask why. Main reason is we can create objects out of that class. Or the object-oriented programming languages provide a way to facilitate creating objects out of the class. Okay. So the customer class represents all the customer objects, car class represents all the car objects, account class represents all the account objects, and so on. And of course, we can create objects. So to represent all these car objects, right, to represent all these car objects, we model the car class. We model one class called car. Okay. To model all the customer objects, we create a customer class. To model all the account objects, we create a account class. And then what we do is, from that class, from that car class, we can create car objects. So that is why we say car class is something like a factory. Right? From the account of class, we can create account objects. From order class, we can create order objects. Okay, that is the idea. Right. So now let's put that into practice. Okay. To represent all the account objects, what we do? We model account class. Remember, from the day one, we have been coding in a class, right? So we say, let's create a class, let's create a class. Why? Because Java language is built for object-oriented programming, not for structured programming. So that is why even when you are doing structured programming, you have to create a class. Actually, it's like, right? So it is supposed to do object-oriented programming, but you have been doing structured programming in Java. Okay. But now only we are going to do the intended thing from Java programming language, that is object-oriented programming. So you can create classes, account class, payment class, order class, okay, vehicle class, customer class, and so on. So that is super easy, right? Class, if you want, you can have public, or you can just forget about it. Class account. Then you can create object like this. So once you have account class, you can say account just like int x. Now you can say account x. But when it comes to variables, you just int x, that's it. But when it comes to objects, you can't just say account x. Then you have to say, you have to create that object. Unless you create object, the object is not yet created. But when you say give like this, the memory is allocated already, because this is just a variable. But objects you have to create using the new keyword. So then only object is created. So if you want another account object, you can have another, say, account A2 equal new account. Okay. That is how now we can see the definition and the practice, right? So account class, still we have not modeled anything about account class, the attributes and behaviors that we can do, but you can see that the account class can act like a factory or blueprint to create objects. Okay. So let's do it as a practical thing. I will be using IntelliJ because it's faster, but you can use command line as well. Okay, let's first use command line, because then we'll move on to IntelliJ. Okay. So let me go to codes, B4&B5. Say 9 OP basics. So I will be using the notepad and command line. Say new text document, then I will say account.java. Okay. So I take a command line also. You can do it with parallelly with me, okay? I'm going to the D, C, D, because my code is in D, okay? Right. So let's create a class. Say class account. So still I have not modeled the attributes and behaviors, okay? Just the class is there. But that is enough to create objects. Right, I just save it. Now I want to compile it. Right, let me close the other things. Right, so I'll say Java C account.java. Okay. We type it again, Java C account.java. Enter. And you can see account class has been created. Okay, account class has been created. Right, now we create another class to test this functionality. I told you these are not serious coding. Okay, this is just to give you the understanding about the concepts. Okay, right. So now let's call this something like account test class to account test dot java. But super important that you do coding, right? Coding කරන්න නැතුව ටිකක් දවස් ගියාට පස්සේ මංජන් වෙලා හිටියා. Right. So this is where you have the main method, because we need a starting point. Always your virtual machine JVM or JRE is looking for the main method of a class. But we didn't do a main method here. We didn't write a plain method. So that is why we want to have it in a different class. Let's say class, say account test, whatever. We'll have the main method, public static void main string array. So whatever. Right, now what I'm going to do is, since we have the account class, I'm going to create a account object. Account, say A1 equal new is a keyword in Java to create objects account. You have to give the case sensitive class name, and here you have to give bracket, starting bracket and ending bracket, because this is where we create the object. Okay, so of course this will not do anything, but just it create a class object of account. Right, so now let's compile this one also. Java C account test dot java. No errors, so I should get another class here, account test. I can run the account test class because it has a main method. Okay, so let's run it, Java account test. And of course, no output, because no system out, println, no nothing, right? It just create a account object. That's it. Okay. And if you want, you can just print it and see whether you can print it, but you will not be able to print it. Dot out dot print ln. You may be getting error actually because this is object, not a string. Remember, println is println expect a object. Okay, sorry, println expect a string. Okay, so therefore, most probably you will get a compiler now. No compiler, but let's run it. Right. So it's basically giving the memory address of the account object. Okay, so don't worry about this. So it says it's a type account at this particular memory address. So memory addresses are given in hexadecimal numbers in machines. Okay. Okay. So therefore, it is not very useful yet, but at least you can see there's object. If you want, you can create another object, but you have to give a different name. Let's say A2. It will have a different memory address because this is a different object. First, I have to compile. And now I can run it. You can see it's a different memory address because that is another object. I will explain what is these memory addresses and so on later. Because you must know A to Z about object orientation, right? At the end of day to day. The A to Z about the basics of object orientation. That is the idea. So you need a very strong foundation. Okay, so now you can see the account class that I created act as a factory to create objects. I create one object, I create another object. Okay. Right. So now let's look at this statement. That is what the statement that we use to create objects, right? So this is where you actually create the object using the new keyword. Okay. So this is we are creating a reference variable for account object. This is something like we say int x. Okay. So there's a difference between reference variable and object. And then this equal mark says my reference variable is referring to this object. Okay, so you create an object, you create a reference variable, that is one. You create a count object, that is two. By equal marks, you say that this reference variable is looking at this newly created object. That is what we do. Okay, so this understanding is important when you if you want to really understand some advanced concepts like polymorphism, inheritance, seriously, not like a baby. Right? So a lot of people, they understand inheritance at childish level and say, I know object orientation. That is why we have interviews. So when you go for interviews, the experienced software developers will check whether you know object oriented concepts in and out. පට්ට ගහනවා කියන්නේ නෙමෙයි. අතින් පයින් නෙමෙයි. ඒක නිසා සමහර ඉන්ටර්විව් යන අකමැති. විනාඩි 5ක් කතා කරනකොට අපිට හොයාගන්න පුළුවන් දන්නවද කයිය විතරද කියලා. කයියයි සර්ටිෆිකේට් එකයි විතරද තියෙන්නේ කියලා. ඉතින් ඉන්ටර්විව් තියන්නේ ඉන්ටර්විව් ෆස්ට් ඉන්ටර්විව් සෙකන්ඩ් ඉන්ටර්විව් මොකද පළවෙනි ඉන්ටර්විව් එක මේ මනුස්සයා හරියට වැඩේ කරේ නැත්නම් දෙවෙනි ඉන්ටර්විව් එකේ දාලා ගන්න පුළුවන්. අනිත් එක්කනට. An interview is not done by individually. So we have interview panel, at least 2 or 3 people, 2 or 3 architects. So they know how to check whether someone knows the subject or not. They know how to check whether you have the skills, you have the attitude. So therefore, don't think that when you get a BIT degree, the බන්දේසියක තියලා කවුරු හරි වාට ජොබ් එකක් දෙනවා කියලා. බන්දේසියක් නෙමෙයි. So that is just give you a chance to call for interviews. Interview එකට call කරයි බොහෝ විට. ඩිග්‍රී එකක් තියෙනවා. එතනින් එහාට ඔයාගේ talent එක, skills, ඔයාගේ attitude වලින් තමයි ඉස්සරහට යනවද පස්සට යනවද කියලා තේරුම් ගන්න. සමහර ඉන්ටර්වියු යන්නෙත් නැහැ අතන. මේගොල්ලෝ දන්නවා මට එහෙම ස්කිල්ස් නැහැ කියලා. Okay, so that is how it works. Now, when you create other object, other account object, say account A2 equal new account, that is another object is created, another reference variable is created. Now it is looking at the other object. So that is why we have one memory location for this object, different memory location for the other object. Okay. Right. Now let's move on to, because our class is empty. Just we have an account class, nothing is inside it. But I told you that now this object, this class represent all the objects, account objects. But I told you that objects have attributes and behaviors. Now what happened to those attributes and behaviors? So we have to take care of those attributes and behaviors in our class. Okay. And this is how you model a class in unified modeling language. We just draw a rectangular shape and give the class name here. Then we write the set of attributes followed by set of behaviors. I told you we have to do some modeling, right? We can't straight away start coding. That is why you have the object-oriented analysis and design subject, modeling diagrams like class diagrams, sequence diagrams. Of course, you can straight away do coding, but for complicated software, we have to do some modeling. Okay. Right. So remember, an employee can have employee number, date of birth, right, and so on. Car class can have bit of behaviors and attributes. A bank account is the one that we are right now modeling. So what are the attributes? Account number, maybe account type. Is it a savings account or current account? What is the interest rate for that account? What is the current balance of that account? So remember, balance means the object. Of course, there's nothing called the account has a balance. In reality, yes, every account has a balance, but in reality, your account has a balance, my account has a balance. So therefore, if your account object has a balance, my account object has a balance, I have to model it in the account class. Okay. So those are attributes. Then we have to model the behaviors. Right. So first we model it, then we code it. Of course, if you want, you can code it without modeling. But for serious level, we need to communicate our design and so on. So then we first model it. Okay. Right. So we'll look at messaging later. Right. So when it comes to class, there are two type of things. Actually, there are three type of things. I will go to the code and explain. That is easier for me. Right. Now you know that we can create objects and so on, right? So therefore now I get back to IntelliJ because it's faster. Okay. So therefore I will just copy these two code and paste it to my IntelliJ environment because it is faster to do code in there. Now here you can see that this is the afternoon we had a class for the different BIT batch. Now we are in the very last topics for them, the swing use interfaces. Now you can see that this is the very first example we did for the UI. Now I told you that even a window is a object, button is an object. Okay, so this is a very simple user interface code using swing. You have the swing later on. Now you can see that this is how you create a window. So for example, now this is a window, right? This is a window. Okay. So how do you create a window in Java? There's a class called JFrame. We have to create an object of that. Then we have to set some properties. Right. So then the window is appearing. I will just run it and show you. Now I'm running this code, you can see window has appeared. So basically what we did, we create a window object. If I need another window, I can create another window object. So everything is object oriented. Even if I want to add a button to this, so then I have to create a button object. So I told you this is the most important topic, because after sometimes everything is object oriented. Button ekat object ekak, window ekat object ekak, database connectivity ekat object එකක්, අන්තිමට හැම මගුලක්ම object එකක්. software developer කෙනෙක්ට. ඒක හන්ද තමයි මෙච්චර හිමින් කරන්නේ මේ object oriented කතන්දරේ. හරි? Right. So anyway, let's delete this because this is not for you guys. Right, I just paste the account class and account test class. Okay, so now we know what is a class, and you know that once you have a class, you can create objects. Okay, right, so your account class, so any class can have three things. That is, you can have variables, you can have methods, and you can have constructors. So usually you have the constructors above. Constructor. So already we have used variables and methods, right? Remember, when I say variables, the global variables, right? Global variables. So basically your attributes will be variables. Right? Attributes will be variables. Remember, the account class can have account number, the balance, interest rate. So attributes are mapped as variables in a class. Behaviors are mapped as methods. Remember, we have the deposit behavior, withdraw behavior, add interest behavior. Remember, those are the behaviors of account. Remember, we assume that the account has those behaviors, others are just calling it. And then we have a concept called constructor. Okay. Right. So we'll take a break. After the break, I will explain there are two types of variables. Some attributes will be instance variables, some attributes will be class variables. Some behaviors will be instance methods, some behaviors will be class methods, and so on. So we will look at those things and we will make our account class fully representing the account, all the account objects. Okay, right. So we'll take a break after. Right. So remember, in a class, we are interested about attributes and behaviors, right? So these attributes will end up as either instance variables or instance class variables. Okay, so therefore now I update this as instance variables or class variables or static. Another name for class is static. Remember, when we did methods last time, I told you make all the methods static, right? I told you that when we use when we do the object orientation, I will explain what is static means. So now we are going to explain. I will explain it. Okay. So every attribute is either instance variable when it comes to implementation or class variable. And every behavior is either instance method or it's a class method or static method. So constructor we will take later. Okay. Right. So attributes are either instance variables or class variables. Now, how do you determine whether it's an instance variable or whether it's a class variable? It's super easy. If every instance have its own value. So instance means another name for object. If every object has its own unique value or own value, not a common value, that attribute must be an instance variable. But if every object get the same value or the common value, for that attribute, then that attribute we have to model or the code it as a class or static variable. Now remember, we have few attributes for the account class. What are those? We have account number, balance, interest rate. Now you know that your account number is different from my account number. No two objects can have the same account number as well. Basically, it's your account number, my account number, someone else's account number. Every account has an account number. That account number is for that account. So therefore, it must be an instance variable. Okay. So if it is instance variable, it's just like a normal variable, but it is directly inside the class. So data type you have to decide. Of course, account number can have letters also. Therefore, it's history. I just say account number, or let's just for to make it short, I will say ACCT now, because otherwise it's too big, too lengthy. Okay. Then what about the balance? So you have your account balance, I have my account balance. If I have two accounts, each account has different balances. So therefore, it's again specific to your object. So therefore, it must be another instance variable. Let's use double because account balance can have decimals. Balance. So then what about interest rate? Now assume this is a specific type of account. Say let's assume that bank has only one concept called account. There's nothing called savings account and blah blah blah. Okay, a small bank for the time being. Okay, so this class is for one type of account. So then whether you have account or I have account or another person have account, everyone has the same interest rate. In general, of course, the bank can give you different interest rate for some accounts. But for a given type of account, everyone must have the same interest rate. Otherwise, the bank is violating policies. They are favoring some customers. So if you have a say savings account in Sampath Bank, if I have a savings account in Sampath Bank, if it is the same type of savings account, we both have the same interest rate. So therefore, that is a class variable, right? Class variable, because it is common to all the objects of the account class. So therefore, I will mark it as a static or class variable. Static. I will again go for double. Say interest rate. Okay, so it is not rocket science, it's common sense. Right. So we have three attributes. Now we have map it to two of those into the instance variable. The other one we map it to class variable. Right. What about the behaviors? Again, behaviors must be either instance methods or class methods. How do you decide whether it's an instance method or class method? If your behavior refer to, that is either read or modify at least one instance variable, then it's an instance method. Right? So that means your method body either read an instance variable value or change the instance variable value, at least one, then it's an instance method. But if your behavior does not read or change any of the instance variables, we can mark it as a class method or static method. Okay. So therefore, let's first take it as instance methods, and if it doesn't access an instance variable, later we'll mark it as a class method. Okay. Right. So let's now, what are the behaviors we have so far? Deposit, withdraw, add interest. Okay. So those are methods. So that is why we did the methods last time. So methods can have method name, Optionally, it can have parameters. Optionally, it can have return. If it doesn't return anything, we say void. Right. So let's take it as instance method, but if it doesn't refer to any of the instance variable, we will take it to the class methods. Okay, static method. Right. So let's say it doesn't return anything. Say deposit. So when you deposit something, of course, you have to tell how much you deposit. Right? How much you deposit. So therefore, let's have parameter for that. Okay, say double, say amount. And now what must be the logic here? So when you deposit a particular amount, what happens? Your balance must be increased by that amount. That is the logic. Right? When you go and deposit 1,000, if your existing balance is 90,000, now it is 91,000. So therefore, what is the logic? Balance equal balance plus amount. Or you can say balance plus C equal. Remember, plus C equal means x plus C equal y means x equal x plus 5. Either you can write this or you can say balance plus C equal. What command? Okay, so now you can see that this behavior refer to a balance because that is the normal thing. Because when you deposit something, your balance must increase by this amount. So therefore, now you can see that it is referring to an instance variable. If your method refer to any of the instance variable, either read the value or change the value or both, it must be an instance method. It cannot be a class method. So therefore, we just keep it as instance method. We can't take it to the class methods. Right? Right. So now what about withdraw? Let's call it withdraw. Take out the money. So then you have to reduce that amount from the balance. Balance minus equal or balance equal balance minus amount. And again, you can see you are referring to the instance variable called balance. So therefore, it must be again instance method. Okay, it must be instance method. If it is a class method, you can mark it as a static, just like here. But you can't mark it as a static. If you mark it as a static, you will get error. You can see the balance is red now. Balance is red. Why? Because it says, now look at the error message. Non-static field balance cannot be referenced from a static method. So balance is not is a non-static field. So non-static fields cannot be accessed by static methods. So therefore, we violate the definition of class method or static method. So therefore, we can't mark it static because we are referring to the balance. Okay. So therefore, we have to keep them as instance methods. We can't mark them as class methods. Right. So what about the add interest? So add interest is called by the bank, not by us. Maybe once a month, maybe every month, 31st or 30th or whatever the last day. So what happens there? So now you have to think about. So to your balance, it add balance into interest rate. Balance into interest rate. Now, right now, we don't have value for interest rate. So therefore, let's initialize it to a particular value for the time being. Let's say interest rate is 10%, 0.1. Okay. Now we can write add interest method. Okay. So let's say it's also void. Add interest. You don't need a parameter because at the interest, you don't say this, you add the interest by this much. It is add the interest by this percentage of your balance. Okay. So what is the logic? Balance equal balance plus, or we can say balance plus equal balance into interest rate. Interest rate we have set it to 0.1 or 10%. So if current balance is 1,000 into 1,000 plus 1,000 into 0.1, that is 100, 1,100. After this method is called. And again, we are referring to balance, which is a instance variable. So we read the value and we change the value. So therefore, again, you can't mark it as a static, or you can't make it as a class method. It has to be an instance method. Now you must know what is the instance method is. Okay. Right. So now our class has two instance variables, one class variable, and three instance methods. Okay. But unfortunately, we don't have a class method. Okay. Not unfortunately, here there's no such a requirement. All our requirements are mapping into instance methods. But just to explain you what is a class method is, I will just write a dummy class method, right? So if it is a class method, I can have static. Right? Let's say void. I will just say something like greeting or something. Just the dummy method, okay? And there I will just have a shout saying, say, welcome. Right? So now you can see that this method is not referring to any of the instance variables. Of course, it is not referring to any of the variables as well. So if you are not referring to any of the instance variables, you can mark it as static. Now this is a class method. Okay. So your class methods cannot refer to instance variable. That's it. But if you want, you can refer to class variable, but that is not a must. The definition is class method cannot refer to instance variable. It doesn't say you cannot refer to class variable. So therefore, if you want, you can refer to class variable. If you don't want, you can refer to none. But you cannot refer to instance variable. The moment you refer to instance variable, that is not a class method or static method. That must be an instance method. Okay. So let's write another class method. Say I want to change the interest rate later on. Let's say I want to do it through a behavior. Let's call it, I'll make it static. Say set interest rate. I want to change it to a new value. So say static void. But I want to change it to this value. Let's say double. Say value. So I want to change the interest rate to the new value by calling this behavior. Now you can see that I am referring to a class variable or static variable, not an instance variable. So therefore I can mark it as a static. Because this is not instance variable, this is a class variable. So of course your class methods can access class variables. Only thing is you can't access instance variables. So now I have two class methods, three instance methods, okay? One class variable and two instance variables. Any questions? So you must know by looking at the variable or attribute or behavior, you must be able to determine, is it going to be an instance variable? Is it going to be a class variable? Is it going to be an instance method? Is it going to be a class method? You must have no doubt about it if you know the concept behind that. Okay. Right. So now since I have the account object, now let's see how to refer to these attributes and behaviors, because we want to access those at variables, call the behaviors from other side. That is what messaging is. Okay. Say I want to set the account number for the account one, A1 dot, you can use the dot notation and set the account number. Let's say, remember it's a string. Let's say 001. Say I want to set the account number of the second object also. Of course, these are not, this is hard coded. Okay. So you don't, in an application, you don't create object and set like this. I will explain how the really things are happening. So that is why I'm telling that this is not a real software. We are just learning what is a class, what is object, what is attribute, what is instance variable, what is class variable. This is like playing. අර පොඩි ළමයි සෙල්ලම් බත්තු වෙනවා වගේ අපි මේ කරන්නේ තාම. හරි. It's 002 and this is A2. Okay. And still nothing fancy we do, and nothing will be printed other than the objects. Okay. Memory locations. But now you can see that we can refer to the instance variables from the reference variable, because this is referring to the first object. A2 is referring to the second object. Now the situation is something like this in the memory. Right? I told you when this line is executed, it shows the memory location of the first object. Okay. So when it comes to computer memory or RAM, when a particular object is created, it allocates memory for that object. So memory has memory address and value. Okay, memory address and value. Say this particular memory address, you can have value, binary value. It depends on, right? If it is a long, say int, it will assign maybe 4 bytes. If it is a double, maybe 64-bit, that is maybe 8 byte, and so on. So how many bytes or how much of a memory is allocated when you create a count object? It depends on how many variables are there. For example, a count class has string variable, double variable. Those are the instance variables. So this is a class variable. Class variables are common variables. Every object is referred to the same variable. So therefore, for each object, you don't need memory allocation for class variables. But for instance variable, every object needs separate memory location. So therefore, there will be memory allocated for a string. There will be memory allocated for string, that is account number. So this is my A1 object, okay? So that is for the account name, so the account number. Then for balance, another few bytes of memory allocated. And that is for your A1. So that is for your A1. Because that's it. And remember, later we create a A2 object. Later we create a A2 object. Now, when this line is allocated, another memory locations, two memory locations are allocated. Another two memory locations are reserved. So one memory location for account number, another memory location for balance, and so on. If you have another object, another two memory locations are allocated. So memory is allocated for instance variables, not for class variables. So when the first object is created in a different location, memory will be allocated for the interest rate. Interest rate. That is not A1, A2 or whatever. It's a common memory location, because every time an object is created, you don't have to allocate memory for the interest rate, because interest rate is a shared value for all the objects. Okay. So that is how it works. And when object is garbage collected, I will explain what is garbage collected later. That means we no longer use object. That allocated memory will be released so that it can be allocated for another program or for the same program. Therefore, when you run a program, the memory goes up and down. Memory usages goes up and down. That is why we say when you are running programs, you need memory. Right? And sometimes memory goes down because at that time you need less memory. When you close the program, all the memory allocated are released to OS. Okay, so every object have its own memory for instance variables, but for class variable, it's just one memory location. Every object is referring to the same memory location. Okay. Any questions? Now you must know what is the instance variable, what is a class variable, right? And you must know that whenever object is created, set of memory is allocated for each object. So memory is allocated for the instance variables for each and every object, but only once memory is allocated for class variables. If you have 3 class variables, 3 memory locations are allocated, but not for each and every object. Right? Now you know how to refer to your instance variable using dot notation as well. Right. Now let's see how can we send messages. Message means you call a behavior. So in object-oriented, we say account test send a message to account 1 object to show this behavior. Say account test send a message to A2 object to show this behavior, show that behavior. Okay. Now let's ask A1 object to show deposit behavior. Again, we use the dot notation, right? So let's say deposit 1,000 rupees. Now remember, right now the balance is 0 because when we are just running the program, we just create an account. Still nothing has been deposited. And let's say A2 objects. Now for the other object, we are sending a message and say, assume that you have deposited, or A2 object account has been deposited, say 500. Say 500. And likewise, we can keep sending messages to different account objects. So right now we can send only messages to A1 object and A2 object because we have only 2 objects. And both are account objects. Now let's say again, say A1 object, I ask it to show the behavior of withdraw, say out of 1,000 will withdraw 200. And for the A2 object, I will send a message and say you have to withdraw. මේක නිකන් සෙල්ලමක් වගේ මෙහෙම නෙමෙයි වෙන්නේ හරි withdraw කරන්න ඔයා ගිහලා ATM machine එක card එක දාලා then I will explain what is happening really. Okay. Say again 200. Now let's print the balance of A1 object, A1 account object and A2 account object. දැන් මේ ඔක්කොම වෙන්නේ memory එකේ. තාම database එකක් එක්ක connect කරලා නැහැ මේක. හරි. Everything is in the memory. When the program is executed and finished, everything will be lost also. Okay. Because we are just learning the object-oriented concepts. So let's say S out. And let's first print the account number A1 dot account num ACCD num, and then we'll print, let's say something like this, and then we'll print the balance A1 dot balance. Let's do the same thing for second account also. A2 dot account number, A2 dot balance. Right. Now what should be the end result? A1's account number must be 001 and its balance must be 1,000 minus 200, 800. Second account is 002. We have set it to 002 and its balance must be 500 deposited, 200 withdrawn. Because they are having different memory locations, it can keep track of individual things separately. It will be 300. Okay, let's run it and see. Right. You can see 001's balance is 800. 002 account objects balance, that is account number 002 object has balance of 300. That is correct. So that means your computer is referring to the correct memory locations. A1 is having separate memory locations, A2 is having separate memory locations. Okay. And the interest rate is kept in a different memory location. Still, we have not referred to interest rate. Okay. Now, what we have done basically, A1 account object is created and we refer to it as A1. So the balance and account number memory is allocated. Then another object is created, we call it A2. Our reference variable is A2. Memory is allocated for account number and balance. So then we set the account number to 001, A1, and for A2 we set it to 002. Then the memory location will have 0001 and 0002. Then we call the deposit behavior for A1 reference variable for 1000, then balance change to 1000. Then we call for A2 reference variable, we call the deposit behavior for 500. Then we call the withdraw behavior for A1 200, then 1000 became 800. Then we call for A2 object, the withdraw behavior, its balance changed from 500 to 300. So that is why finally we get 800 and 300. Because when these two lines are executed, this memory location has 800, this memory location has 500. So basically we are sending messages to our account test class is sending messages to A1 object asking deposit, asking withdraw, then A2 object asking deposit, asking withdraw. Right? When we send message to the account test class send message to the account objects, its relevant data is affected. Right? A1, when we send a message to A1 object, its balance is updated. When we send a message to A2 object, so A2 object means A2 dot withdraw, A1 dot withdraw. That is, we are sending message to A1 object referred to as A1. Sometimes we send message to object referred to as A2. Right. That is how it works. Okay. What is wrong with this code? Okay. So do you have the account class? Is it IntelliJ or something else? No, this can't be IntelliJ, right? So first of all, you must have compiled the account class. First of all, you must have the account. Yeah, this is the account class, right? No, maybe you have not compiled the account class. And account class and account test class must be in the same folder. And first you have to compile the account class. Then account class must be there in the folder. Then only you can compile the account test class. So it says account class is not found. Right? Account class is not found. So that means maybe you have not compiled the account class. Maybe you straight away try to compile the account test class. So that must be the reason. Okay. Because if account class is already compiled and it's available, you must not get this error. Okay. Right. So just double check. Right. Now let's call that interest behavior also. Again, we are sending a message to the A1 object referred to as A2. Okay. So let's call that one also. A1 dot add interest. It's an instance method. You don't have to send any parameter. A2 dot add interest. And then we'll again print the two values, balance values for A1 and A2. Remember, we are adding 10% interest. So therefore, this must be 880. This must be 330 because remember, these are instance behaviors at the interest. Right. Now let's see whether we get 880 and 330 also after that message. Yes, 880, 330. Now remember, you add the interest method, refer to the interest rate. But interest rate is a common. Right? Common because it's a class variable. It's not an instance variable. So every account object see the interest rate as 0.1. Okay. So this is what class, object, instance variable, class variable, instance method, class method, messaging. Right? Now we are sending message to different objects from our account test class. Okay. Any questions? Let's get back to our note. Right. So what is messaging? An object calling behavior of another object. Object or main class. So far, what we are doing is not objects calling a behavior of another object. Basically, what we are doing is our test class sending messages to two objects. Both are account objects. Okay, both are account objects. If you have another account object, we can send message to that account object also. Okay, so let's take a little bit more serious example because so far we have only one class. In a software, it is not one class, right? We have the account classes, customer class, right? And so on. Different objects. Okay, sometimes one account object is communicating with another account object, right? And so on. And maybe SMS objects are there. Sending a SMS is also creating SMS object and calling behavior. Okay. So let's assume we are doing a payment. Say this is an online shopping application or something. So we have the customer. This is we are just showing it as a scenario rather than a formal diagram. So customer is basically customer object in object-oriented terms. So then we have payment object because customer is going to do a payment. So therefore, the payment class or the payment object has payment-related behavior. So the customer object is going to call maybe pay behavior of the payment object. Okay, pay behavior. So now we are looking at the system. What happens? So we have, it will create two account objects. This is basically what happens in the bank side. Bank side. Okay. So this is what happens in the portal or the sales side. This is happening in the bank or bank system. Assume that the customer also has account. The vendor also has account. Let's assume both are having the same account, same bank, they are having the account. Say I am having Sampath bank account. When I do the payment, my vendor is also having account in Sampath Bank. Otherwise, it's a system-to-system call, which is more complicated. Right? So you can see the reality is not simple, right? So that is why we need engineers. That is why we need smart people get into IT field and do things. Right? We just think of a very oversimplified scenarios right now. We are not looking at the reality yet. In reality, my account is say in Sampath Bank, my vendor's account may be in commercial bank. And this is happening in say Abans.lk website. So many systems. And then to verify my card, they have to send message to a MasterCard or Visa, which may be in USA. So many things are happening in the background. Okay. But we are not still looking at, that is why you have subjects like enterprise application development, web application development, okay, mobile application development, and so on later on. So we gradually look at the reality. Right now, we are not looking at the reality. Then medical college එකට ගියාම ඒ මෙඩිකල් ස්ටුඩන්ට් එකපාර සර්ජරි කරන්න දෙන්නේ නැහැ නේද? මේගොල්ලෝ තාමනේ මල සිරුරක් කපලා බලනවා. ඒ වගේ චූටි චූටි වැඩ කරලා බලන්න තාම. ඊට පස්සේ තමයි අන්තිමට අවුරුදු 5කට 6කට පස්සේ කියන්නේ දැන් ඔයා කෙලින්ම ලෙඩුන්ට බෙහෙත් දෙනි. ඒකත් සීමා වාසි පුහුණුව කියලා යවලා තව අවුරුද්දක් විතර ට්‍රේන් කරවලා ඊට පස්සේ අවුරුදු දෙක තුනක් OPD වල එහෙම දාලා නේද? ඊට පස්සේ තමයි කියන්නේ ඔයාට ඕන නම් දැන් ඔයාගේ ලකුණු හොඳ නම් ඔයාට දැන් ස්පෙෂලිස්ට් වෙන්න යන්න පුළුවන් සර්ජන් කෙනෙක් විදිහට. ඔන්න සර්ජරි එකක් කරන්නේ මිනිහා මෙඩිකල් කොලෙජ් ගිහලා අවුරුදු 10කට විතර පස්සේ තමයි ඉස්සෙල්ලා සර්ජරි එකක් කරන්නේ. Because it's so much of responsibility. Right? පළවෙනි සර්ජරි එක කරලා තියෙන්නේ මෙඩිකල් කොලෙජ් ගිහලා අවුරුදු 10කට විතර පස්සේ. මහුමත් දාන්න පුළුවන්. හැබැයි සර්ජරි එකක් කරන්න දෙන්නේ නැහැ. බයිපාස් එකක් කරන්න දෙන්නේ නැහැ එකපාරට. Because the reality is not as simple as what we know. Right? And not everyone becomes a surgeon. Not everyone becomes a surgeon. Not everyone become a neurosurgeon. Right? Not everyone become a cardiologist. So likewise, so we gradually, right? එකපාර මේ අලියල්ලන්න බෑනේ නේද? සමහරවිට තදියම තියුණානේ, සමහරවිට දෙන්න තදියමකුත් තියනවා නේද? එහෙනම් තදියමක් බෑ. ඉවසගෙන ඉන්න ඕන. ડોක්ටර් ඉවසගෙන ඉන්න බෑන අවුරුදු 10ක විතර පළවෙනි සර්ජරි කරා. But we don't have to spend that much. But still you have to understand gradually topics. Right. So say customer is sending the message to pay. Then the payment object is sending one account object to, that is customer's account, to debit. Debit means reduce money from that account. Let's assume both are in the same bank. Message passing. So then, just like our withdraw method, customer's balance will be reduced by the amount. Okay, maybe when this is done, that account object will send a message to the SMS object of the same system, say notify the customer. So then SMS object will send the SMS via the service provider, and customer will get the SMS. But that is not enough. Now money is deducted from the customer's account. Now money has to be added to the vendor's account, because this is a payment for buying something. Now the payment object will send a message to the other account object. That is also account, but this other different account object, which is initiated for the vendor's account, to credit or add that same amount. Then of course it will send another notification to the customer or customer system. Maybe it's a web service call. Someone customer SMS maybe a web service call or something, some sort of a notification. And you can see a lot of messages are passing. Let's assume that all things are happening in same system, but in reality these are happening in different systems, and some more objects are involved which we have not shown, like logging the transactions and so on. Okay, validations and so on. This is again oversimplified version of to show you that when a particular transaction is happening, so many objects are involved. Sometimes more than one objects of the same type or different type of objects, payment object, account objects, notification objects, and a lot of messages are passing. Message passing means one object calling behavior of another object. Okay. So gradually you have to familiar with this if you want to do object-oriented programming. That is why I told you object-oriented programming is not for kids. That is why these are not taught in schools. But while loop, right? If else, yes, those are taught at schools, even grade 6, 7. But how can we teach this kind of a thing for a grade 6 students? Object-oriented. Okay. Right. So then we discussed that your variable contains data and it needs memory. Method constraining some process logic. Basically, when a method is called, your processing is used. The computer's processing is used, and of course, the methods will refer to variables, instance variables or class variables, mostly instance variables. So therefore, those values can also be changed, like updating when the deposit is called, the balance is up change. Right. So we'll look at the constructor later. Okay. So remember, attributes will become either instance variables if every object must have the specific its own value. But if it is a common value for all the objects, we will mark it as a static variable like interest rate. And again, we have instance methods and class for the static methods. Right? Instance methods are methods that refer to instance variables. Class methods are methods that do not refer to instance variables. So this is the difference between instance variable and class variable. So each instance gets its own value and memory location. Class variable, a common variable for a class or objects of that class. So here you don't use any specific keyword, but class variables, you have to use the static keyword. So instance variables can be accessed through object references. That is why we say A1.account number, A2.account number, right? But class variables, still we have not directly referred to the class variables. Class variables can be referred by class name. That is the preferred approach, or you can use the reference variables, but that is not the preferred approach. Still, we haven't done that. Okay, we will do that later. And these are some examples from account class. Candidate for instance variables, candidate for class variables. Right. So then you must know the difference between instance method and class method. So instance methods are methods that refer to at least one of the instance variable. Right? Refer or access. Access means either you read the value or you change the value. But if the method does not access any of the instance variable, you can call it a class method and you can mark it as a static method. Okay. So instance methods can be called using object references. That is why we say A1.deposit, A2.deposit, and so on. A1.add interest. But class methods, still we have not called class methods. The preferred way of calling class method, or that is what is being messaging class method, is using the class name. But if you want, you can refer to class method using instance references as well, but that is not the preferred way. So these are some examples like deposit, withdraw, add interest. Those are candidate for instance methods. Maybe change interest rate and so on, which you are not referring to instance variables, are candidate for class methods. Okay. Right. So before moving to constructors, let's see how can we use class variables and class methods as well. Okay. Right. So here we have a class variable called, the account class has a class variable called interest rate. Now, of course, we have referred to the interest rate from our instance methods. Right. That is internally. But now let's see how can we from outside can we refer to the class variable. Now remember, from outside we refer to the instance variable using the dot notation. So similarly, can we refer to the class variables, say interest rate? So the preferred way of accessing class variable is not using the reference variables of your objects because they are not bound to their objects. Rather, use the class name, say account dot, and you can see the interest rate is there. Say I want to change it to say 0.2. 0.2. So that is how you refer to a class variable or static variable. You preferred approach. Use the class name, dot notation, and access the variable. Now, remember, we have only one memory location allocated for interest rate. So every object is looking at the same variable. So therefore, now if I add interest for A1 and A2, both will see the interest rate as 0.2 because this is a common variable. Okay, this is a common variable. This is a common variable. Right. So now let's call the add interest again for both the objects because add interest is the instance method. Now it must be, okay, let's change it to 0.01 because otherwise the calculation is a little bit tricky. And then key then another 880 into 0.01 is 8.8, right? 8.8. So here 3.3, rupiah 3, rupiah 8.8, rupiah 3.3 because now it's no longer 10%, it is now 1%. I change the interest rate to 1%. Okay, so now let's print. And both the accounts have this effect because interest rate is a common variable. It's a class variable that we change to 0.0. You can see 880 and another 8.8 rupees is added because now the interest rate is not 1%, sorry, 10%. Now the interest rate is 1%. For 330, only 3.3 rupees and 3 cents have been added because now the interest rate is 0.01. So this is how you refer to the class variables. Preferred way. But if you want, you can change it like this also, but that is not the preferred way. Using any of the reference variables, you can refer to the interest rate. But that is not the preferred way. That is why when I use the dot notation also, it doesn't show it like that, but it is possible. But that is a bad practice. So you can see we can do it like this. But this is not the preferred approach. Preferred approach is use the class name. Okay. So this is valid, but not the best practice. ඒ කියන්නේ මොනවාද? දැන් පාරේ වම් පැත්තෙන් ගියා කියලා කවුරුත් ඔයාලට දඩ ගහන්නේ නැහනේ. වාහනයක් ගියොත් නම් පොලිසියෙන් දිනනවා. හැබැයි පාරේ ගියා කියලා දඩ ගහන්නේ. That means it's valid. නීතියෙන් කියලා නෑ පාරේ වමෙන් යන තහනම් කියලා. But that is not the best practice. Best practice is go by right side. So this is something like this. Your compiler will not give you any errors, but this is not a best practice. So best practice is you do like this. ඒකට හේතුව මොකද්ද කියලා ඔබ්ජෙක්ට් ඔරියන්ටඩ් කරනකොට ඔයාටම තේරෙයි. මේක ටිකක් මහා විකාර වැඩක් කියලා. හරි? මෙහෙම කරන එක එච්චර හොඳ නෑ කියලා. ඔබ්ජෙක්ට් ඔරියන්ටඩ් concept තේරුණාට පස්සේ තේරෙයි මෙහෙම කරාම අර විකාර වැඩක් කියලා. හරි? දැන් ඔයගොල්ලෝ දැන් සමහර මිනිස්සු විකාර වැඩ කරනවා. ඒ මිනිස්සුන්ට තේරුම් නැහැ විකාර වැඩක් කියලා. හැබැයි සමහර මිනිස්සු කියනවා කල්පනා කරලා බලලා මේ මුන්ට පිස්සුද මේ විකාර වැඩ කරන්නේ. හැබැයි ඒගොල්ලෝ සෙට් එක විකාර වැඩ කරනවා. ඒ වගේ තමයි. හරි? ඔබ්ජෙක්ට් ඔරියන්ටඩ් දන්න කෙනා තේරෙනවා මේක විකාර වැඩක් කියලා. ඒක හන්ද ඉස්සෙල්ලා ඔයාලට තියෙන විකාරද නැද්ද කියලා වෙන එක නෙමෙයි. ඔයා ඔබ්ජෙක්ට් ඔරියන්ටඩ් ඉගෙන ගන්න. ඔයාටම පස්සේ තේරෙයි මේක නෙමෙයි හොඳ විදිය මේක කියලා. Right. So that is how you refer to the class variables using the class name. And similarly, if you want to refer to the class methods or call class methods, again the preferred way is use the class name and call the class method. Okay. For example, I have a method called greeting. So the preferred way is say account dot greeting because it's a static or class method. But this is also okay. A1 dot greeting. But again, this is not the preferred way. Okay. Allowed but not preferred. Not the best practice. Okay. valid but not the best practice. So therefore, I will comment that line. And similarly, rather than you set the interest rate like this, we could have set the interest rate using that set method also. Right? Account dot set interest rate. We can get it back to 0.1 or maybe 0.1. Maybe 0.1. Okay. So these are okay because we are just using the class name to refer to class methods and class variables. But these are okay, but valid, but not the best way to do this way. Okay. So this is also valid, but not preferred. That is doing this set interest rate. A1 or A2, whatever you want. Okay. So this is also valid. You can see no compile errors. Right? But this is not the best practice. Best practice is use the class name when you are referring to the class methods. When you are referring to class methods, class variables, use the class name. Right? Use the class name. Right, now you know how to access class variables, class methods using the class name, the preferred way, and how to refer to the instance variables and instance method using the references, object references. And now we are in a position to discuss constructors. So then we are done with the basics. Okay. Right. So I just keep some comment for constructor. Now constructor is, now remember I told you when we create an object. That means memory is allocated for instance variables. And if this is the first object of that type, that class, memory is allocated for class variables also. But class variable memory is allocated in a common area. Right. So that is done for you by Java. You don't have to do anything. Right? You don't have to do anything. So those things are automatically happen. But if you want to do anything special at object creation time, some initialization, getting a database connection, and so on, initializing some values, you can have your constructors also. But having a constructor is not a must. It's optional. But if you want, you can. If you want, not if you want, if there's a need. Of course, we always do something if there's a need, not because we like. Say we have a need to do certain things at the object creation time. So then we can write a constructor. So constructor is something like a method, but its name must be same as case sensitive class name. And it must not return anything, not even void. Now in a normal method, if you don't return anything, you have to say void, but constructor must not return anything, not even, you must not even write void, because if you write void, it will become method, not a constructor. Okay, so let's copy the class name. Right. So if you want, you can have parameters, but no return type. Okay. This is a constructor without any parameters. For the time being, I don't want to do anything special, but I just want to put up a message saying account object is created. Just to see whether the constructor is getting called. Now we are creating two account objects here. Here, in both the cases, the constructor must be called because now we have a constructor. And this must also be printed at the very top, right? At the very top, if the constructor is properly called. Let's run it. Right. I accidentally click on the debugging, but anyway, it will run it because there are no debug points. Let's run it on debug. Let me close everything. Right, run. Right. So you can see account object is created. That is for this line. So then we print the memory location of the object. Then when we create the second object, again it's a count object is created. That means our constructor is called 2 times because we create 2 objects. So what is the constructor? Constructor is in your class, which will be called when object is created, which is optional anyway. So when you create a constructor, make sure it's like a method, but its name must be case sensitive class name, and it must not return anything, not even void. If you want, you can have parameters. If you have parameters, when you create object, you have to send the arguments. Right. So now we are done with the basics. Okay. Again, go through the note. Right. It is called automatically when an object is created. Cannot be called at any other time. We can't call it at any other time. Methods can be called at any time. Again and again, you can call methods. But constructor is, you can write the constructor in the class, but it is automatically called when the object is created, and that's it. Afterwards, you can't call it. So we can use it for initialize variables, getting some resources, and so on, right? So those things you will learn when we are doing database connectivity, user interface development, and so on. Right? So its name must be same as case sensitive class name, and it must not return anything, not even void. Okay. And this is our full class now, right? With our instance variables, class variables, constructor, some instance methods, some class methods, and so on. Okay. This is our test class. Right. Now this diagram is super important. Right. Super important. So I told you, when you create an object like this, because you must know A to Z about what you are doing. So this is where you create object. That means the memory is allocated for instance variables only. මෙම ඇදලා ඇතර මෙහෙම දෙයක් වෙන්නේ නැහැ ඔබ්ජෙක්ට් එක ඇතුලේ. හරි මේ පස්සේ කෝල් කරන්න පුළුවන් කියලා පෙන්නන්නේ. මෙමරි allocate කරන්නේ නැහැ නේ methods වලට. So when the second object is created, again memory is allocated, and now we refer to it as A2. Here we refer to it as A1. So it's something like a remote control. This remote control is referring to this object because we have the equal mark, and this remote control is referring to this object. So therefore, whenever you refer to A2, you are referring to this. Whenever you refer to A1, you are referring to this. So they are two independent things. Okay. And you can see that interest rate is memory is allocated separately only once. Whether you create hundreds of objects, still only one memory is allocated because it's a class or static variable. Okay. So then your reference variables, you can call the instance methods. Right? Instance methods, and instance methods have access to your own variables. Your own variables. At the memory game methods okay. Now you can see that here I have shown full green line, green arrow. Here I have used dotted line. So that means this is okay, but not the best practice again. When we say encapsulation and data hiding. Data hide karanno. Right? So therefore, we have shown it like a dotted line. So that means this is allowed, but not a best practice again. That means doing something like this is not a best practice. Right? It's not a best practice. So that is why we have something like this, so that you will learn when we discuss data hiding. Okay. This is the best practice. If you want to change the balance deposit or withdraw, this is not a good thing, but this is allowed. Allowed. Don't do it unless you have a very good reason for that. Okay. So why you will learn when we do some other database object-oriented concept. Remember, we have a few more concepts like inheritance, polymorphism, abstraction, encapsulation, and data hide. Okay. And again, you can see that you can refer to your class variables and class methods using reference variables, but that means it's allowed. But that is again not a best practice. Allowed but not best practice කියන එක තමයි dotted lines වලින් පෙන්නලා තියෙන්නේ. Allowed but not best practice. So this is the best practice. Using the class name, refer to it. Okay. And of course, your instance variables can refer to class variables and class methods. So that is fine. And also your class methods, instance method referring to your instance variable is fine. කොළපාට solid දිරි කියන්නේ කිසි game එලකිරි කවුලක් නැහැ. කොළපාට dotted line කියන්නේ allowed but not best practices. Right? එනට බං තව තරක පෙන්නලා ඇති සමහරට red වලින් ඒ කියන්නේ එහෙම කරත් එහෙම compilers එනවා. ඒක කොහොමද කරන්න දෙන්නේ නැහැ. So this is how we do it in best practice manner. ඔක්කොම මෙතන තියෙන තනි කොළ පාටේ වගේ. කැඩීරිත් නැහැ. That means your reference variables calling instance methods. Your instance methods can access instance variables, and of course instance methods can call other instance methods, and of course instance methods can access the class methods and also class variables, right? So that is fine. So that is how the normally how when we develop the software, these are the things that we usually do in our code, right? Reference variables calling the sending message to the instance method can access instance variables, instance method can call other instance method can access class variables, instance method can call class methods. ඔන්න ඔය ටික තමයි සාමාන්‍යයෙන් අපි කරන්නේ. අනිත් ඒවා කරන්න පුළුවන් සමහර දේවල් උනාට ඒවා කරන්න හොඳ නැහැ. සමහර දේවල් කොහොමවත් කරන්න දෙන්නේ නැහැ. ඒ හොඳ නැත්තේ කරන්න දෙන්නේ නැත්තේ කියන එක ඔයාලට ටික ටික තේරෙයි. හරි? The more you understand, more you will the more you have experience, the more you will understand. Right? Remember, this is formal science. At the end, you must be able to understand 100%. ඒ කියන්නේ ඔයාට තේරුම් ගන්න පුළුවන් වෙන්න ඕන මේ වෙලාවේ software developer කෙනෙක් වාඩි වෙලා කෝඩ් එකක් ලියනවා නම්. එයා ලංකාවේ වෙන්න පුළුවන්, Microsoft එකේ වෙන්න පුළුවන්, කොහේ හරි Google වෙන්න පුළුවන්. ඒ level එකටම ඔයාට තේරුම් ගන්න පුළුවන්. එහෙම බැරි කමක් නැහැ. එහෙම බැරි කමක් තියෙන්න බෑනේ. For example, I have worked in Oracle projects, Oracle company projects වල වැඩ කරලා තියෙනවා, IBM එකේ projects වල වැඩ කරලා තියෙනවා. එහෙම ඒගොල්ලන්ගේ engineersලත් එක්ක අපිත් වැඩ කරනවා. ඒගොල්ලන්ගේ කොටස් develop කරනවා, අපි අපිට දීලා තියෙන කොටස් ටික develop කරනවා. ඒගොල්ලන්ගේ calls වලට තමයි අපිත් යන්නේ. එහෙම කරන්න බැරි කමක් තියෙනවා මෙච්චර එහෙනම් අපිට මේ බය නැතුව කතා කරන්නේ නැහැ නේද? අපිට එහෙම කිසි බයක් නැහැ. ලංකාවේ software field එක ලෝකේ ඕන field එකක් එක්ක ඉන්නවා නේද? අපි කියන්නේ ලංකාවේ තේ ලෝකේ ඕන තේකොළත් එක්ක තියන්න පුළුවන් කියලා නේද? එහෙමනේ කියන්නේ නේද? ලංකාවේ තේකොළට බය නැතුව කියලා කියනවා මේවා සිලෝන් ටී. එලකිරි තේකොළ. ඒ වගේ තමයි අපේ IT කරන කට්ටිය. හරි software developers අනිත් පැත්ත එක්ක උරින් නුර ගැසිලා එකම ටීම් වල එකට වැඩ කරන්න පුළුවන්. ලංකාවේ ඉඳලා හරි පිටරට ගිහිල්ලා හරි ඒ level එක maintain කරනවා අපි. ඒකෙන් කියන්නේ හැමෝටම මේ level එකට එන්න පුළුවන් කියලා. ඒ level එකට එන අය තමයි ආයතන වලට ගන්නෙ. හරි. ඉන්ටර්විව් කරලා. මොකද ඒගොල්ලෝ සමහරට මාස 3ක් යනකොට ඇමරිකාවේ, බ්‍රසීලයේ, සවුත් අප්‍රිකාවල හරි ප්‍රොජෙක්ට් වල වැඩ. කොහේ ගිහිල්ලා වැඩ එක්ක මේ ඉඳන් වැඩ. Right. So these are not so good practices, okay, but allowed. Right. And also your constructor has the access to the instance variables, class variables, and your constructor can call instance method. Your constructor can call class methods as well. Those things you will see gradually. Okay. So this is the big picture again. So your reference variables call the instance methods, and instance methods has access to instance variables, and instance method can call class variables and so on. Okay. And these are the not so good thing to do. Okay. කරන්න පුළුවන් හැබැයි it's not a good thing to do. ඒක දැන් කොළ ඉරි නෙමෙයි තැඹිලි පාටේ කඩ ඉරි කරලාම දාලා තියෙනවා. කරන්න පුළුවන් වුණාට එච්චර හොඳ වැඩ නෙමෙයි ඔය තැඹිලි ඉරි වලින් තියෙන්නේ. හරි. තැඹිලි ඉරි වලින් තියෙන්නේ. Right. So think about why aren't class methods allowed to call instance methods? So class methods cannot call instance methods, but instance method can call class methods. Okay. Think about why. Think about why it is best practice to access variables through methods. ඇයි අපි variable method දරා call access කරන්නේ direct call access කරන්නේ නැතුව. That is what I mentioned here. So here I told you this is not a best practice. The best practice is if you want to say, if you want to change the interest rate, don't do this, rather do this. If you want to change the balance, call the deposit method, withdraw method. Don't go and set the balance directly. Why? Think about it. Okay, think about it. Right. So we stop at this point. So next time we'll look at what is abstraction, what is encapsulation, what is data hiding, what is association, what is inheritance, what is polymorphs. Okay. So that is our next set of tasks. Yeah. But it will take another 2 sessions. Okay, another 2 sessions. Okay, right, we stop at this point. I will share you the code that we did today after the class. Okay, right. We stop at this point.